Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the implicit differentiation, which is an important method to find the derivative from an implicit equation. Let's see the materials. Okay, so here. And first, I will introduce the method. Okay, then I will practice three questions together. We will practice three questions together about how to use the method. And we have the first question here. Can you see? We have equation, and this equation we call the implicit equation. Okay, the equation tells us the relationship between x and y, which means if we know x, then we know y. Therefore, y should be a function of x. Okay. However, we don't know what is the explicit function of y, right? Of x. And our purpose is going to find the derivative of y to x. How to do this? And we just say that it's impossible to find the explicit formula. Why? Because if you go to Google, okay, to search Abel, okay, Abel's impossibility theorem. Abel's a very famous mathematician in the history. Okay, the impossibility theorem tells us it's impossible to find a general solution just using radical. Okay, for this type of polynomial function with the degree greater than 4. Now we have the degree is 5. Impossible to find a general solution. And specifically for these questions, we never find the solution. Okay, we never find an explicit solution for y is a function of x. And so how to find the derivative? We have a method. So this is this topic. What we are going to do, we call the implicit differentiation. Okay, all we need to do for this method is going to differentiate both sides of the equation. Can you see? Take a derivative to x to the left side, to the right side, and therefore we have a linear equation. Solve the linear equation, we get what we need. Okay, so in this method, all we need is these three. So the first is chain rule. Okay, so we learned the chain rule before. The second is Leibniz notation. It's better to use Leibniz notation. Later you will see. And the third is how to solve a linear equation. Of course, solve linear equation the easiest, right? We know these three parts. Therefore, we know how to perform this implicit differentiation. And let's go to see. Okay, so we were going to answer these questions by using implicit differentiation. Okay, can you see? All we need is take a differentiation, take a derivative to both sides. Okay, differentiate both sides. Okay, so we are going to perform. Can you see? Here is the equation, right? Here is the equation. Okay, so how to find the derivative? Let's going to see. So we're going to get. And do you remember? So in the method, it says all we need to do is take a derivative to both sides, right? But we need to see y is a function of x, which means we have to use the chain rule. Okay, so let me see here. All we need to do is differentiate both sides. Okay, let me write here. Is differentiate both sides of the equation. This is all we need to do, of course. This is the most important. Let me write a little bit more steps. Okay, and we have three terms, a combination. So we need to use the linear property of derivative. Can you see? Take a derivative to the left side, so we get this. The first we're going to dx. Okay, we said it's better to use Leibniz notation, which means this operator. Do you remember this? Okay, the first term. This is the derivative to the first term minus derivative to the second term. The second term is y. Take a derivative to x, which means dy dx, right? The second is dy dx. Okay, can you see this? So the third term is minus x squared, take a derivative, of course. is a minus, I wrote one more step, is at this x squared. So the right side, this is the differentiate to the left side. Differentiate the right side, which means dx at 1. Okay, so that's all we need to do the first step. I wrote all the details. Now we're going to find all the derivative one by one, term by term. Okay, how about the first term? Let me see. And this is the most important. Can you see y raised to the fifth power? What's this function of x? This is a composite function of x. Okay, composite. Y is a composite because y is a function of x. Is not a power but the composite. Okay, can you let me put here? Okay, so all we need to use is the chain rule for this first derivative. We have to use chain rule. And I'll write the answer for the first term. Chain rule is this. We have to do this. And the two derivative term together, right? The derivative of the outer function times the derivative of the inner or the derivative of the outer. Okay, the inner is y. Okay, can you see inner function is y. Y is a function of x. So you can say u equals yx. Okay, u equals y. Therefore, the outer function is just a u raised to the fifth power. Or we simply say is y raised to the fifth power. This is the outer function. Is a power function, right? Power function, take a derivative is easy. What is the power? Is 5 times y raised to the fourth power, right? This is the derivative of the out. What is the derivative of the inner? The inner is just a y. Or u equals y, right? Okay, so you can directly is u take a derivative to x, which is y take a derivative to x. Therefore, which is dy dx is this. See, that's the chain rule we used. Okay, now we're going to the second term. The second term I just copy is dy over dx. How about the third term? The third term is easy, power function, right? So directly minus 2x. Everyone know. And what the right constant function take derivative is 0. And go to here. Now is easy. All we need to do is what? Can you see dy dx, dy dx? The power is 1, no power, which means this is a linear equation of dy dx, right? Is this a linear equation? Yes. Okay, so let me write here. All we need to do now, we get a linear equation. Okay, I simply say this is a linear equation. Of course, a little bit of difference. A linear equation of the variable this time is dy dx. Okay, the variable is not x as the previous one. Okay, how to solve this? All we need to do. Okay, linear equation, everyone know how to solve, right? So first, put everything of the variable together, which means compound like term first, and then divide it by the coefficient. So I will going to do these two steps. And this is the variable. This is the variable. What we can do? Combine this variable together, which is a compound like term. Let me put here. Okay, so I will going to compound like term. So here is do this. We're going to compound like term. Okay, we have two like terms, right? Okay, they are the first and the second. So after we combine them together, see what I get. We should get this. This is the coefficient times dy dx should be equals what? This is linear equation, what the coefficient. So easy to see. The first coefficient 5y fourth power minus the second 1. Okay, so easy to put it here. Is 5y raised to the fourth power minus 1, right? It's good. This is the coefficient. What is the constant term? Of course, we have a negative 2x to the left plus 2x to both sides. We get a 2x to the right, right? So here is 2x to the right. And now look, it's much simple. What do you do now? Just divide it, okay? So I was going to do divided by what? Divided by the coefficient. What the coefficient? 5y fourth power minus 1, right? This is the left, so I will do the same to the right. I will do the same to the right. Also divided by that term. See, I will put it here. So we divided by 5. Can you see? 5y the fourth power minus 1. So here the same 5y to the fourth power minus 1. And then we can cancel the coefficient, right? Then that's already the answer. Okay, so I put a little bit there. One more. Can you see? What I get now is the answer for the first questions. What is? So we get this. We get a dy dx equals. And all we need is just a copy. Let me just copy. And this term we get. Okay, so this is already the answer, right? So I copy put here. Can you see? Here is already the answer. Okay. So that's the last for the first question. And does this make sense? The method? Okay, so let me go over a little, because for the other questions, we have another 2 questions do the same way. Whatever we have an implicit equation, just differentiate both sides. But keep in mind that where is the most important, that when we meet the composite function, use chain rule. Okay, so can you see here? Let me highlight it. This is the most important. Okay, don't miss this part. And after this, we just solve a linear equation, right? Okay, let me look at the one more. Okay, these questions, you will see it's almost the same. We have a explicit equation, okay, and of course this we have a formula to solve for y, but the formula is complicated. It's a lot of radical. Okay, it's too complicated to solve for y. And then now we just use the implicit. Okay, so how to do? Differentiate both sides. Remember, that's all we need to do, right? Do this and just differentiate all the same, both sides. Okay, so then what do we get? We have 3 derivatives added together. Use the sum rule. So the first term is this, is d dx for x raised to the fourth power, right? Okay, let me write it. The second is d dx to x squared times y squared. The third term is this, is d dx y raised to the third power. This is the left. Derivative of the right, of course, you know that's 0, but I wrote everything here together. Okay, so then what do we do? One by one, term by term. Okay, so I'm going to get what the first. The first is the power. Of course, what do we get? It should be 4 times x raised to the third power, right? Good. How about the second term? Be careful. The second term, see, x squared is a function of x. Y is a function of x. Therefore, y squared is also a function of x. There's a product of 2 functions. Take a derivative. Do you remember which rule to use? Product rule, right? Good. Let me write here. This we have to pay attention. Okay. And we have to pay attention to this. Let me put it. This is the what? This is just a product rule. Okay. So let me put here. We need the product rule to solve for this. Okay, let me write the product rule. Now what do we get? You know the product rule. The first take derivative and then the second take derivative. The first derivative, I wrote all the steps. Can you see what do we get? Is d dx. The first is x squared, and then times the second is y squared. Okay, it's better I put this bracket to separate this. This is the first, and then I plus the first x squared times the second derivative, right? Is this. So dx, and then we have y squared. And for this is the product rule, but we use the Leibniz notation, so you remember it's exactly the same as the prime. Now we move to the third term. How do you think about the third term? Y is a function of x, therefore y raised to the third power is a composite function. What do? We have to use the chain rule. Okay, the inner function is y. So let me see up here. What we need to use now is the chain rule. Okay, so for this term, we have to use a chain rule because this is a composite function. Okay, let me write it, the chain rule. What do we have is this. Okay, so the first out y raised to the third power, right? Because u is y, so u raised to the third power is a product, is a power function, right? Power, which means 3y squared. This is the out. So the inner, of course, is dy dx. That this makes sense. The chain rule, that's the most important. Keep in mind. Still, okay, this is the most important. Pay attention. Be careful about this. And then equals, of course, that's 5. And okay, so now we move to this equation. So the second term, this is easy, right? The third term, pay attention. The third term, this is what? Chain rule again. Okay, so as we used it there, let me just copy a little. So we have almost the same as this. We have to pay attention to this chain rule. Because what? Y is a function of x. If I put it here, can you see? This is the chain rule. We have to use it again. Okay, we have to use the chain rule again. Let me write down what we get. Okay, here is what we get. So we wrote step by step first. Okay, so they are the same. A copy is 4 x the third power. The second, can you see x squared divided is 2x, right? So we have 2x times y squared, and then plus, okay, x squared times, let me put x squared times a big parenthesis. Be careful about this because we have to use chain rule. So what is the inner function? U equals y, right? So u squared is y squared. Take divided to u is a power. So 2 times y, right? Let me use this color. So we have 2y. This is the derivative of the outer. Derivative of the inner, of course, is dy dx. That is makes sense. Chain rule. Okay, so I copy one more term, which is 3y squared dy dx. Okay, this equals 0. Can you see? It's the same as the first question. So what do we get? We get a linear equation of dy dx. So how to do? Let me put here how to do. Of course, compound like term, right? So what do we need to do? We need to compound like terms. Okay. So we have one term here and another term here. Okay, put them together. See what I get. So I will get this. And the coefficient, and then dy dx, and then equals. Okay, so what is the coefficient? The first is I will change a little bit the order. 2 times x squared times y. Okay, so I put here. So 2x squared times y. Okay, what is the second coefficient? 3y squared, right? So we put here 3y squared. Good. This is the coefficient. What is the constant term? Okay, constant term is these two terms, but we need to move to the right. Therefore, we have to subtract these two terms. Okay, if I subtract which means negative, I put this parenthesis. Okay, 2xy squared. Can you see? Almost right. Now, how to do? This is the coefficient divided by the coefficient both sides. So we solved dy dx. Okay, can you see what is dy dx? Of course, we have dy dx is this, which means the derivative. Okay, so it's a negative. Okay, let me use this. That's a fraction, right? So a little bit longer fraction. So we're going to, sorry. So we're going to just copy what do we get. So this will the one we will get. Okay, and then we're going to copy here the first. Okay, so I'll copy this, right? This is the numerator. Good. And what is the denominator? Let me copy. Okay, so this is the numerator. Okay, I have to put this back. This is the numerator, right? Okay, what is the denominator? How we're going to do here should be the denominator. Okay, let me copy to there. See, this is the answer that we get. Okay, so it's a fraction, whatever. Look at these questions, almost the same as the first question, right? Okay, it's the first take the differentiation. Okay, the second solve the linear equation, so we get what we need. Let me work one more question. Is still the similar. Okay, so suppose we have this implicit, but this time we have sine and cosine trick. Do you think we can separate the x and the y to solve for y? Impossible, right? As you know, it's impossible. So what do we do? Take derivative, okay, to both sides. Now it's still the same. Okay, so we have to do this. Differentiate. Okay, sorry, we have to differentiate both sides. Differentiate both sides. Okay, now this still the same. We're going to write the original, which means d dx. This is take a derivative, right? And of cosine x times y. This is the left. What the right? We have two terms. Of course, easy. The first term won't take a derivative. The second term is this. And the sine y take a derivative. Okay. One by one, we'll look at the first. What do we do? The first, which rule we need to use? First, I look at the function cosine x times y. This is not a cosine x, okay? And the variable is x times y. Therefore, this is a composite function. A composite function, we have to use chain rule. Everyone know this. We have to use a chain rule for the first term. Okay. Let me write this down first. What the chain rule? Chain rule is always do this. The first term and the second, right? The first derivative, which is cosine u, right? Cosine u is negative sine u. U is x times y. Can you see here the derivative of the outer? Now, derivative of the inner is not easy to get directly. So I just put the detail. Can you see what is the inner? The inner is x times y. Is this the derivative of the inner? Yes, right? Because this is u. Okay, whatever we use the chain rule now, I will go to the right. The right is easy. What is one take a derivative, which is 0? What is the second sine y? Pay attention, okay? So here is the chain rule again. Is the chain rule again. So let me put here. So it's the same. Okay, can you see here? Okay. Or simply say like this. We also need to use the chain rule because what? Because sine, this is a function. However, the variable is not x. The variable is y. Y is a function of x. Therefore, this is a composite function. Okay, so we have to use chain rule. The inner function is y. Always keep in mind. So I put it here. Whatever the chain rule, we need to do two steps, right? Find the derivative of the outer. Of course, it's sine y or sine u. This is the outer. Sine take derivative is cosine. So I will get a cosine y. What is the inner? Inner is y, right? Y take a derivative to x. So dy dx. Okay, can you see? Now, what do we get? Almost. So we get one more term. So here, okay, we need to simplify. Think about this term is x times y. Okay, x is a function of x. Y is also a function of x. What do we do? Product, right? So for a product, what do we need to use? Okay, and this time we have to use the product rule. Okay, because this is a product. Can you see here? Let me write down. This is a product, so I have to use a product rule. Does it make sense? Okay, so let me use the product rule, see what I get. I will get this. I will get a negative, I'll copy the first, okay, is negative sine x times y times, okay, what is the second? Product, we have two terms, so I use this parenthesis. What is the first? X take a derivative, right? Product rule. X take a derivative to x is 1. So the first term is just y. Let me write that the first is just y. I use this color. What is the second? Okay. The second is the first x times derivative of the second term. Second term is we use dy dx. We use dy dx. Can you see this? What we use the product rule. And then we're going to the right. Of course, I ignore the 0. I copy cosine y times dy dx. Almost. So now what do we get? We get a linear equation. Now is dy dx the variable. Okay, so linear equations, what do we need to do? Just a compound like term, right? So can you see? And this term and this term is like term. So we do this. We just compound like terms. So these like terms are 2. Okay, after we put them together, see what do we get? We will get this big term. Okay, so let me write a little bit of long term, and then times dy dx equals, what's the coefficient? Let me look at it. The first coefficient is negative sine times x, right? The second is here on the right side, we should minus, therefore we get a negative, and the first also negative. Is better I put the negative outside. And then the first I change a little position, which is y times sine at x times y, right? Okay, the second you know now is cosine y. Good. This is all the coefficient. Okay, and what is the constant term? I think I made a mistake. Okay, see, here should be not a y. Okay, so pay attention, be careful. This is what, see, x times the sine, so should be x. Be careful, here should be x. Okay, this term is x, right? That makes sense. Okay, so now what is the constant term? Constant term is y times the sine, negative to the left. So we plus this big term both sides, therefore we have positive, right? So I wrote down is positive sine x times y. Now you know what we need to do. Okay, divided by this coefficient of both sides, and easily to get what is dy dx now is this. We should have a big fraction, of course. So this is the big fraction. Okay, let me move a little bit to here. And what is the numerator? Okay, the numerator is this term, and the denominator is a negative. Okay, so it's better I put the negative to the top. Okay, so you see, and so for the top is just a negative. Can you see? For the top is a negative. Negative what? Negative of this term. I just copy this term. Okay, so we will have this is the numerator. What the denominator, of course, is this term, right? Can you see? And the x are already put it to the top, so don't worry. Okay, let me copy. What do we get? Okay, so I did not copy the where. Okay. Then we're going to find that the denominator is this term. Okay, I'll copy the denominator and I will put it here. See, that's all we get, right? Okay, the final is this answer. That does make sense. That's the method of implicit differentiation we learned. Okay, that's all. Thank you. And if you have any questions about this topic, please leave your comments. If you like this video, you are very welcome to subscribe to my channel for more videos. In the next video, we're going to see. Okay, so we are going to deal with the derivative of inverse trig functions. Okay, and we were using implicit differentiation we learned in this video. Hope to see you next time. Thank you. Have a nice day. Bye.